The problem wasn't worded exactly this way, but it's kind of the gist of it, and the picture is the same. Okay, but if you want to find the surface area of a triangular pyramid, whose base is an equilateral triangle and whose the height of the solid itself is 10 centimeters, okay, how would you go about finding that? Okay, so the first thing I would suggest, Maddie, were you going to offer a suggestion? Oh. Do you have a question about what one of the words is? Okay. On this, if you sketch out what you have, you should always start any of the problems with sketch. So our base is an equilateral triangle. So if I sketch that, label it with as much information as I can, so I know the actual length of the side, so I can label it here. Okay. And then the height of this pyramid. So since it's a pyramid, all these vertices are going to meet at one common point, the vertex. Okay, so here would be my sketch. I can identify the height of this as 10. And so here's as much information as I know for this problem. Okay, so my total surface area is going to be my base shape plus how many lateral faces are there? How many sides are there other than the base? There's one for each side of our base. So our base is three-sided, so there's going to be 3, and then the shape of those lateral faces are triangles. So what we're really doing is we're taking our base and we're adding the 3 triangles. All those triangles are exactly the same. Are they all equilateral triangles as well? Not necessarily. And so that's where the confusion and the extra work comes. Okay. Now, it shouldn't be a problem to find the area of the base. Okay. We've gone through that before. So if we take our base shape, and let's say we sketch it right here, 12, 12, and 12. What is the area formula for that base? 1/2 base times height, where the base is 12, and our height, when we draw in our height here, what does that do to our base? Cuts it in half, so this length is 6. And what kind of a triangle is created here when we draw in that altitude? Since it was an equilateral triangle, this half of an equilateral triangle is 30, 60, 90. So if we use the patterns for 30, 60, 90, we have the side opposite. 30 degrees is 6. The hypotenuse is double that, 12. What's the side opposite? 60 degrees? 6 root 3. Okay, so we can plug that in. We have our half of 12 is 6. 6 times 6 gives us 36 root 3. So we have 36 root 3 for our B value. We found one part of our total surface area. Okay. So once again, that part shouldn't be a huge burden to solve. Okay, the problem comes, how do we find these lateral faces? So to represent that, I'm going to write A sub F. F just represents the faces. Okay, these are all triangles as well, so the area formula for each one is 1/2 base times height. The base is given. Here is our lateral face, right here. So our base is also 12. But what we don't have is this corresponding height. I'm going to call this H sub F. It's the height of the face. So we don't know what H sub F is. If we did, we can find the area of each face, multiply it by 3, and add it to the base area to get our total surface area. Okay, so in order to find this height, if we connect where the H sub F intersects this base of 12 and connect that to our center point, the center point is where the vertex is perpendicular to the base. Okay, on any regular polygon, which is why I'll always use regular polygons, including the equilateral triangle, this vertex will always line up directly over the center of our base shape. So the center of our base shape is going to be right here. And if you recall from the chapter dealing with triangles, that center point is actually the point of concurrency for all the different measures that we looked at. It's the in-center, circumcenter, centroid, orthocenter. Okay? And so we see that the point where this lines up and forms this right angle, we have a height of 10, so we know one leg of that right triangle is 10. The other leg is you can either think of it as the apothem of the regular polygon, or in this case, we have a specific relationship for this. This portion of the median, based on the fact that that's a centroid, is what fraction of the whole thing? You guys remember that from the last chapter of the triangle. The centroid cuts off a median into a ratio of 2 to 1, which means the smaller portion is what fraction of the whole thing? 1/3, right? So if the whole thing was 6 root 3, what does that leave for this smaller portion? 1/3 of that, or 2 root 3. So we have this length of 2 root 3. We have a leg of 10. And so we can find this h sub f by using what? We have a right triangle with 2 legs. To find the missing hypotenuse, we can use Pythagorean Theorem. So we can say 2 root 3 squared plus 10 squared. The sum of the squares of the legs is equal to h sub f squared, the square of the hypotenuse. So we can just solve this. 2 squared is 4, root 3 squared is 3, 4 times 3 is 12, 12 plus 100 gives us 112, is equal to h sub f squared, extract the square root. So h sub f, this height, is actually equal to the square root of 112. So if we take half of 12, which is 6, times root 112, there's the area for each individual triangular face. We have 3 of them. So if we take 3 times 6 root 112, add that to 36 root 3, that will be our overall surface area. All right, now, again, it's not an easy process. However, once you've gone through it or watched it being done, now it should be. You should be able to follow these steps and solve the exact same way.